So another extended writing one, as I said before, just pause for a moment and plan what you're going to write. Remember as well, when you're doing the extended writing ones, that it won't be all new physics. A lot of those kind of set explanations that you've learnt by heart will be useful parts of an extended writing question. So get those in there, in the language, in a detailed language that you've learnt them, to make sure you're picking up as many marks as possible. 18. Student observes a parallel beam of light through a polarizing filter. Aha, good old polarization then. Polarizing filter is rotated through 2 pi rads in its own plane. So actually this is a kind of standard explain question of how polarization works. What else do they want me to do? The intensity of the light transmitted through the filter varies as shown. Well, that's a nice little sign relationship, isn't it? What do they want me to do here? Aha, okay, it's a quality of written communication. It's a extended writing question. So I'm going to pause for a moment because I've got about 6 minutes to do this, so I'm going to do this really, really well. Explain the observed variation intensity of the transmitted beam. Okay, so I can do that, but on the face of it, it's a really, really simple question. But they want a good bit of writing from me. So I'm going to have a little plan. I'm going to try and think 1, 2, 3 paragraphs maybe. Firstly, well, let's define what's going on with the polarizing filter. So I'm almost just going to define polarization, or I'm going to say what the polarizer does. They're looking for linkings. They're looking for linkages. So I'm going to try and link that into the idea of, well, these points here, these minimums, these 0 transmitted intensities. So I'm going to explain the zeros and talk about why they're at 0, pi, and 2 pi, which are like the multiples of pi, if you like. Okay, pi being equivalent, of course, to 180 degrees. So essentially, they've just rotated it once, and they've seen this. Here in 3, then I might talk about the maximums here. Okay. And the maximums are at pi over 2, and they are at 3 pi over 2. Okay, so that's my little kind of structure I'm going to try and write to. Does it talk about, it says a parallel beam of light, and that's the variation. So the light itself must be polarized, okay, initially. So that might be an interesting thing to say as well somewhere in there. So my final kind of conclusion, if you like, would be light must be polarized, the incident light. Because maybe you're familiar with the idea, if you want to test if something's polarized, then you rotate a polarizing filter through. If it wasn't polarized, you wouldn't see this curve because you just get all the light coming through. All right, so let's go ahead and write my little statements then. Define polarization. So we say this light is plane polarized. As I write, I'm going to reread and think, reduce the oscillator to one plane around its direction of travel. I can improve that probably to one plane at 90 degrees to it, or perpendicular. Okay, and don't be afraid of doing that. Yes, it's quality of language. Just put a line through it right above it, okay, or put an asterisk and write here or something. Do edit your writing as you go. Okay, well, what's happening here? My second paragraph, I decided I was going to talk about these 0 points. So at 0 pi and 2 pi, there is a minimum, or there is 0 light intensity transmitted at these angles. Let's have a little read. At 0 pi and 2 pi radians, there's 0 light intensity. This is because the polarizing filter is perpendicular to the plane of polarization of the light at these angles. Okay, so I could talk a little bit more. What do I mean by the polarizing filter is perpendicular? So the plane of transmission, let's just use that term in there. of the polarizing filter is perpendicular to the plane of polarization of the light at these angles. Okay, that makes sense to me. What about at the maximums then? That was my third bit. Pi over 2 and 3 pi over 2, the light transmitted is maximum. As the plane of transmission is the same as that of the light. Okay, let's put like oscillation, shall I? I've kind of already inferred this, but I'm just going to sum it up by saying this evidence shows that the incident light is already plane polarized. Okay, I hope that makes sense. I would really encourage you to do that on the extended writing questions. I've got a student who actually, every time he sees one, he makes the plan and then he leaves it and he comes back to it. But what I would also encourage you to do is once you've written it, read it again and do these little bits, adding that extra level of detail that you think might be on the mark scheme. I know they're hard. You have got the time to do it, so just pause, think before you write, because this is the length they're expecting. They're not expecting way more than that. If you've got elephant handwriting, they're going to put extra paper at the back, but don't just start writing. And the worst thing you can do is, if you don't know what you're writing, just carrying on. If you've written something you think might be relevant and you've just carried on that thought, you're probably just going to end up repeating yourself. So pause, think about what you've written already, correct it, edit it if possible, and think back to the question, what other details might you need to add? So this next question is much more like the kind of standard explain polarization questions. So you're given two pairs of identical sunglasses. Some of them have got polarizing filters. Simple test to determine whether sunglasses use polarizing lenses. No longer assessed on the quality of writing, but you're probably going to get the idea. So view some light through both pairs. Of glasses. Rotate one through 90 degrees. Now that's what they're going to be looking for. Have you said something about perpendicular, or use the idea of 90 degrees, or obviously pi over 2. Went 1 to 90 degrees. That's your first mark done. So if you notice light intensity varying, then they have polarizing filters. So that's pretty easy. Thank you very much for the marks. Okay, really that one was more straightforward than it maybe seemed at first. So pause, think, what can I apply? What part of my physics that I understand well can I apply to this context that I've been given?